wood for my next solar device, then a second one, number 2. So I have this nice thick pipe, cut to length. This is a curved surface, all the wood. Now I just have to find out how I'm going to get this all on the bike. It's going to be very tricky. Most worried about this board. I mean, you get a lot of wind force lift and drag out of that board on the bike. A lot of trouble. Okay, so I got all the stuff that I need for the next solar device. Pretty excited. Got this nice big pipe, got everything, the boards, I cut out the curves. So that's all the wood I'm going to need to build it. It's pretty heavy, it's quite a bit. Now I have to try and see if I can fit it on this motorcycle. I was going to put one across, but I don't think I have to worry about the width. I mean, I'm just about as wide as a car here. This is a 5-foot pipe, and everything else is 4 feet. So I'm going to try and get everything across like this on the back, and just fill the back out and behind me, and then I have 4 straps. I probably should have bought more, so let's see if that works. If not, I have to pay for a cab or get someone to deliver it, so that's going to suck. So let's see if this works. Okay, so you just finished putting all this stuff. This nice guy, Fernando, helped me put all this stuff on it. I tried to give him a tip, he wouldn't take it, but finally he did, just like $2. But yeah, so we got 2 pipes, got these big 2x10s, and I really hope nothing moves. It should be interesting driving. Basically I have a wing on the back of the bike, so either it's gonna, right now it looks like it's gonna create a lot of drag and downforce, so I don't know. I'm gonna try and drive really slow. Kind of worried that something's gonna happen, and all those damn speed bumps, so I'm trying to avoid those, but I just don't want to pay for a cab. Safe at home, everything's off the bike. I just drove really slow, like 40, I think I went 50 for a second there for a while. Didn't really notice any force with the stuff, but it's all off, and I'm ready to build solar. So here's the pipe we're going to use. Then we're going to take this cap. It has these hammer wedge things on the inside. We're going to hammer that in with some silicone as well to seal it off. That's going to be the sealed end. On the other end, we're going to pour water in. We're going to have to put some pieces on that in order to use it in horizontal. But for now, we'll be able to boil water in the vertical position, get some data just that configuration, and then we'll keep going. Just silicone this, put a little more. So we want this to stay airtight and pressure tight, and then we bang fit this on, which is also siliconed on the inside. So we're hoping these together will be airtight. But we should have got the gun. We didn't get the gun for the silicone, so it's very tricky. So I'm still building the solar device. I have all the wood there. I started cutting it, got all the curves cut. So then we have the 2 curves cut for the parabola shape. It's hard to see underneath there. And now I got a thick board. It's a 6mm board. It's about the thickest board that you want to bend. So it's pretty tricky to bend. Usually I want to go for like a 5 or a 4mm board, but this one really holds its shape well. It's not going to warp as much, and it's just more accurate. So I really made it heavy duty. I mean, like, this supports everything 2 inches, or it's a 2x10 that I use. So I'm having all this water here to weight it down, and I'm slowly wetting the board, and I have a pretty good setup here. It's kind of by accident that all the water drains out into this bucket here. So I just wet the sponge, and then I just cover all the board with water. I want to make sure this gets nice and soaked. It just bends a lot easier when it's soaked. Dry board is more stiff, and you can see it just drains the center and drips into the bucket. So I'm going to keep bending this. I still have quite a ways to go. I mean, it's bent pretty good, but I have another 5 inches or something to bend until it gets close to the curve there. And I can just keep building. I had some problems with the pipe. Here I had a leak here with the silicone, so I just used a normal fence post cap. It's just some shitty metal cap, and then we just cover the inside of silicone, and here it's leaking already. So I'm thinking under pressure, for generating any kind of electricity or pumping water, you probably need about 15 to 30 psi. With the hot water, I think I might need a different way. I'm going to try a clamp with rubber maybe. The open boil it just to get some data on how long it takes to boil. This might work. I have to see. I'll have to try and clog that one little hole. Right? Till next time.
Here's our pipe for the solar device. We had it nice and sealed with all the silicone at the bottom. All the way around. It leaked at the beginning, but now it looks better. And all night we had it with some water in it, and we didn't get a leak, so this is good. This should be good for the unpressurized version. We have to make sure just that the heat won't be a problem, but we're going to boil water just like it is with it almost full, so it doesn't spill out. Boil water and maybe put a steam hood on to collect steam. And the next step after that would be to create a sealed chamber to create pressure to run things like turbines and stuff like that. So should be ready to test. Just getting the board ready there. And you start drilling things probably together, assembling it together, and then putting the tube up, and then we should be ready to do our first test. A little piece of pipe. This is the rubber piping used to attach to the copper pipe. We're boiling it to make sure it can take the heat, and it seems pretty fine. It gets a little soft, but should be good for what we're doing. Just to make sure it's food safe, so there's no chemicals in the water that comes out of the distillation.
This epoxy thing is so cool. As you're pushing it, it mixes. It goes back and forth. You see that? And it's mixing the two layers together, so you can just apply it nicely. You don't have to pre-mix on a jug. So I'm gluing these extra pieces that are there on here so I can keep going with the curve, and then I can cut out the last part of the curve, so it should be good. There it is, a drill connected to this socket. Hopefully I can use this on my ratchet now. The socket was $1 and the set of drill bits was $2, so it's much cheaper than buying an automatic drill, and I'd like more of a hand drill so I can ratchet that and drill the pilot holes for the solar device.
Okay, good morning. So the solar's still ready now. So again, what this thing does, it takes sunlight, reflects it on an object like this, and it all comes down. This one focuses at 5 inches above the surface, so from here up to 5 inches. So I have the small, they sell orange juice here in Mexico in these really strong metal bottles, so this is actually perfect for what we're looking for. It's another piece of garbage, so you can actually close it and make it airtight, which we don't actually need because they're not going to pressurize it, but it could be done. We'll place that there. You can just close this. You put it here. Has a little thing to hold it in place there at the back. And then the sun comes up. It reflects perfectly on that. So I'm going to try this out now. I'm going to paint it, but I also want to try it without paint. Just if you found in the garbage you didn't have paint. But all this is garbage material. The only thing I use is white glue, some scissors, a ruler, pencil. That's about it. This side is attached with glue stick. It worked a lot better. This is a chip bag, so it holds its shape a lot better than tin foil, so you need something strong to hold it in place. And this side here is just held on with regular dish soap. It didn't work very well at all. It's all separated. So I'm probably just going to test it the way it is and then switch this over to the glue stick. But yeah, chip bag. So cardboard I found from the carnival here. It's just a piece that they use to, just thick, it's not corrugated, it's just like a bunch of sheets that are glued together, thick cardboard. And this is actually a cereal box on the outside. So I'm hoping to be able to boil water in this small thing. It's just a small version of the bigger one that I'll be building or finishing hopefully today, where I'm going to boil water in a pipe. This is just a quick garbage version. You can see the workmanship here is pretty bad on purpose. I just cut it up really quick and threw it together. And yeah, it worked quite well. So hopefully it can boil. Here it's quite easy to angle this. I mean, just prop it up by placing anything in the back here, and you're directing it here into the sun. You can tilt it and make sure it's pointing to the sun. And here, I just glued a bottle cap here for a gauge to see where the sun is, so if you create a shadow on the different sides, you can see if you're pointing directly at the sun. And then that's it. I should get some hot water.
Oh wow, that's coming on thick. That's really nice. It's pretty shiny still. Nice. So first solar data test here with the garbage thing. We're gonna focus it on this can that we have painted. We're gonna put, I think, about 200 milliliters of water in it. And then we have this nice temperature gauge where we measure with this this thing the internal water temperature. I'm gonna graph that and see how fast it warms up. So the water temperature now is 30 degrees. It's gone up 2 degrees in the last, I think, 3 minutes. And it's nice here. I'm just in the shade, having a great time. I really enjoy this kind of stuff. So there's 300 milliliters of water in there. It's all from garbage, and I'm just watching the temperature go up here from the shade and recording it. So yeah, life is good here in La Paz. First screw in the sheet, nice and flush. Perfect. Ooh, I don't know if I'm downwind or not. Oh man. Am I? Yeah, this will make it definitely heat up better with the flat block. Sorry? Nice job, babe. So yeah, we pilot drilled this with a ratchet to save money not getting a drill. Broke off. Shit. Okay, and now we put all these screws in. So I guess now we're screwed. So this is a small garbage soil. Building the big one over there. And this one, just the chip wrapper is doing pretty good. You can see bubbles in there actually, it's hard to see. So it's just starting to boil. Lots of little bubbles, but you see all the light here that's reflected. So it's all the light that comes in here, goes boom, and hits here on this pop can type thing. But it's so hot, I can't touch it. So yeah, there's light here at the bottom on this side, and there's light on the bottom on this side. So it's actually reflecting very well on the bottom of the pipe. So you can see that right here. I'm really excited to see this boil because it was free, just built out of garbage. So very cool.
It's at the end. It's scratching the shit out of it.
Oh my god.
Fuck. I need something.
Blue. Oh wow, that's pretty good. It's all grain. That's why we have to sand it more.
You're never gonna get the grain out of the wood.
You can try.
As much you can sand it as much as you want. You'll never get the grain out of the wood.
Really good. Premium tinfoil. So with the laser pointer we can check this mirror is working well. There should be a red.
There's still a lot of soap on this.
Should be red light on the pipe there. Oh, nice. So no matter where the light hits, if it hits head on like the sun, it all goes on the pipe. And we just have to cover the rest with tinfoil and we're good. Spreading out the glue. That's a lot of glue. Too much glue. Glue works so good. They're gluing it. Oh wow, it's such a mirror. Right there that you just did. You can see perfectly what you're doing. This is really good. So with the laser pointer we can check to make sure that it's always going to hit. That's where the pipe is, somewhere around there. And you can move it back and forth so that's all the sun energy that hits this mirror. It's going to go on the pipe. But it just depends on the angle. So when it goes too far down it just means I'm angling it wrong. So if it's something like that, maybe to maintain the angle, the sun should come straight in. It looks like it's good, so we've done a great job making this mirror. I'm just cleaning it up. But yeah, the reflections in it are just, it's amazing. You can see like the cornflakes and everything. So we had no idea tinfoil would get this good. I'm really excited to test it out tomorrow.
Solar device is ready to go, and of course it's cloudy. Crap.
Graphing.
Just act natural.
Yeah, so we're graphing the different angles of the sun, and if they hit this pipe here, and all the lights, so I have to change the angle. And yeah, we're doing this instead of a computer program, because I don't like computers. And here, we've got all the points, this is how we graph the curve. On 3 more degrees. Stupid 80. Just a little bit more. Oh, big solar. I'm just about to shut this solar down. Little garbage solar. You can see some steam coming out there. It's I think it's about 86 degrees now. It started slowing down. It's just so much heat lost because it's so hot, especially on the bottom where all the water is. Now I'm gonna switch to the bigger one. Looking forward to that boiling. I mean, it's just the alignment here is horrible. You can see a huge shadow here with the sun alignment. And just having sit here is just where it's stored, and it's super hot. The pipe you can't touch at all, even though it's completely off angle. So really it shouldn't be heating up at all, but it's that little bit. So we're really excited about that. This thing's really putting up a lot of steam now. Yeah, it says 84 degrees, so I went down a little bit. I took off the insulation off the back. Yeah. This thing is heating up so fast. Okay, when it went in, it was 29 degrees. And in the last couple of seconds, it's gone up like 6 degrees. The old solar, the garbage, there you go again. The old garbage solar I had, and there's not a lot of reflection at all. That means there's so much light energy that's going into this pipe. Like, look at that. That's what my hand reflects. It burns like hell, and the pipe reflects nothing. So all that is going in. Wow. 96. That is a lot. So we have our sundial here, little shadow at the bottom, just because it's too low. I can't have it go back further. You have water that's, you can see there is 1.5 liters of water. We have our temperature probe in there. So there's a section here that's not covered with water, so that's not good. It should be a little better. We should lean it back a little more. And here, these are my 2 marks. If I miss this 4.5 degrees offset, that means the tube is tilted too much and the sun's going to miss it. So let's make sure we stay in there. 38 degrees. Wow. So that's our setup right there. It could be a little lower. I think I'm going to adjust it so it's a little lower. More of our water gets heat. So this is water temperature we're getting now. And it's at 41 already. And it's only been going for, I think, 3 minutes. So it's just crazy. Like, this here must be really hot. I'm afraid it's going to burn the wood. It's a great sun. So yeah, it's perfectly aimed at the sun now. So you have to track it. This, because the sun moves this way, so it's going from east to west, like that. This shadow would start lengthening as the sun's more over that way. And this is my line. If it's past this line, that means it's going to start missing the pipe. As long as I'm within there, I'm fine. It looks like I'm perfect. And this is this way, how far I tilt it back. So I got this smaller can here so I could tilt it further back. That also lets the 1.5 liter come further out this way because it's less of an angle. And the more water is pulling in the heat, the better. Also, I'm afraid I'm going to wreck this gauge by burning the cord, because the metal by itself gets really, really hot. Pretty sweet setup here. I'm just taking all the numbers down quickly as a solar thing. And I'm just inside the doorway, and out there is a solar device. And I just have a little gauge here that I can read from in here. I don't have to get too hot. That's it. It's really nice. It's already 66, I think, 65 degrees. Oh, there's 66, so yeah. It should boil pretty soon. Boiling now pretty good. It's been at 100 for maybe 5 or 10 minutes. See the steam coming out, and you hear it. Yeah, it's pretty exciting. It's about half an hour to boil 1.5 liters of water with the sun. Not too shabby. Looks like I'm going to have to adjust this soon. It's creeping over, so turn the thing around, but yeah. Cool. 100, boiling. 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 Sweet. Still boiling.
How long did that take? Like, not even an hour.
It was 33 minutes. So it's quite a bit of steam. But I'm thinking, I mean, there's just a couple little wisps. There's not that much steam. If I want to run anything that's steam powered, I'm going to need quite a bit more. I don't know if I need maybe a longer pipe. So this section of pipe will create this much steam, but if I have like a 10-foot section of pipe, it should be 5 times more steam, right? But I don't know, maybe still can boil up a little more. I have some shadows that are coming over here, so I have to move it over here into better sun. So I can do that now, and then continue. I got 101 degrees Celsius reading, so I guess that's the error of the gauge is still showing 101, which is wrong, I guess. 101, 101, I don't know what that means. You can see the steam coming out, and you can really hear it. It's boiling pretty heavy. Still boiling really strong. I just need to find out now if there's enough volume. You can feel that there's, whoa, quite a bit of steam coming out of there. Doesn't look like a lot, but it's because of a big tube. So I'm going to put a small 1/4-inch tube on this, and that's what would be running like anything steam powered or pumps. And also, same 1/4-inch brass pipe would be used for distilling water. So it's quite a bit of water, and I think it's boiled down quite a bit of the water. So what I'm going to do after this, I'm going to measure the amount of water that was in here, and I found out how long it was boiling. That'll tell me how much water is boiled per minute or per second, whatever. And that'll tell me how much steam I might be able to condense into drinking water from salt water or another bad source of water. But just to be able to boil 1.5 liters of water in half an hour, to be able to drink that, is really good to be able to remove some parasites and kill those parasites and bacteria and that kind of stuff.
Really thick here. And then
Second layer. It's a lot of silicone on this thing. Nice and insulated. It looks like way too much fun. Also frustrating at the same time.
it's like icing a really sticky cake.
Wow, it's like 1/4-inch thick. Really nice.
Alright, so these are all the parts I need for the condenser. The condenser is going to attach to this solar pipe. So this will go on top of the solar pipe. Then I'll drill a hole in the back. I'll put a small piece of copper pipe, just a 1/4-inch copper pipe, and I'll have this 3/8-inch plastic tube that I'll attach from there. That'll go over to another piece of copper pipe, which is going to be wound inside this pop bottle. This is going to have colder water in it, so the steam is going to go from the solar pipe through to that pipe and go through this condenser, and it'll condense and we'll have distilled water on the one end, and this will also warm up water that you can put into the pipe next, so that the next water in the pipe will boil faster. I'm doing tests to see how fast the water boils off again. It's about 10:30, so the sun isn't really in its prime. I'm also adjusting it to the line, so I'm going ahead of the sun, like I am now, a little bit ahead of the sun. I'm letting the sun track over. This takes about 40 minutes to go from one side to the other, and the whole time it's running pretty heavy. It's pretty much at full power as long as the sun hits it on both sides. A little too much insulation on this side, which we're going to cut off. You can see that the sun's kind of hitting the bottom part of insulation. We're going to cut that off. Other than that, it's going great, and it's boiling pretty heavy now. I've never really seen it boil this heavy. I wish you could see it. It's really hard to see, and it's basically covering my camera in steam on my phone. So just at the top there's this rolling boil that's going crazy. So what I'm going to do is I'm going to measure how much water is lost. Probably going to run it for an hour and a half. It's already been an hour, but I had a can on top of it to keep the water vapor inside while it was warming up, and I only removed it once it started boiling. So this is the steam that's produced with a full pipe, 1.5 liters full of water for this configuration. That's the amount of steam that you could use to run something. Also the steam we'd use to distill water or whatever, but there's quite a bit of steam coming out of there, so it's really exciting. So I'm getting ready to freeze water in this 1/4-inch copper pipe, so I can bend it to the small bends that I want to fit inside the condenser. So here I just took some high temperature, which wasn't required, but it was in a better tube. I mean, I have this stuff, which is really easy to apply. The big stuff, I just make a mess and it go all over the place. But I just put a little bit of silicone in the cap, and make sure you have the drill bit also to drill this out if it gets stuck and it's hard to pull out. So I'm going to let that dry. Then I'm going to fill the entire pipe with water, and I'm going to cap this end the same way. Let both silicone dry, and then I'm going to put that in the freezer. A couple hours in the freezer should be all frozen, and then I can quickly bend the bend I want. And what's going to happen is ice is going to stay inside the tube and prevent it from collapsing when you do a tight bend. So yeah, should be good, and then condenser should be done. For this side, I'm going to take this small piece of copper pipe. I'm going to drill and insert it into here. I'm going to glue that in there nice, and this is going to go on top of the pipe, and so I'm going to have a small pipe that's going to come out, which is going to go to the rubber and then to the coiled up piece. Condenser coil. Still full of ice, huh? Okay, you have to make them like the same length, kind of, and point out at the same...
Okay,
You're doing a good job.
do
You're doing a
this.
good job. You're doing a good job.
I don't know what like, this is not the easiest material to...
Yeah, I know. It's fun, though.
This is as good as I can get it, so...
The coil's all done. We're just taking the silicone out and draining the water and seeing how well it flows. We have a couple kinks. The ice really helped a lot, but we still had a couple spots where it kinked a little bit. I mean, it's pretty goofy, but I think it'll do the trick. That's about
Silicone's still gushy.
3 feet.
It wasn't dry.
Well, just as long as it capped pretty good, the end was dry. So this is our condenser coil. We had a couple kinks. We're just checking to see how good the flow is, and it seems like there's quite a bit of water coming through. There was ice in it. We pushed that all through, got rid of the silicone. Seems to be working good. So we're excited to distill some water using sunlight. It's ready. It's done. Just waiting to dry. So I angled it so I'm trying to get none of the coils to hit the sides. It'll be hot. I mean, not that hot because there's going to be cool water in this and the steam that's entering here. So especially the first turn will be pretty hot. And as it goes down, it's going to cool down and start condensing. And Kenneth did a great job here with all the silicone. So just gob silicone on both sides to seal it. Same at the bottom, which is going to have more pressure because of hydrostatic pressure. So that's actually more important than the top one. We're going to fill water to about here, right in the top. And then the hot steam is going to go through, so it's going to slowly heat up this water, as well as condensing for condensed water. And then this water is going to heat up, and we're going to put that back in the solar device for the next round, where it's going to be hotter and we won't have to heat it. So we're recovering some of our heat, as well as condensing the water that we've steamed. I mean, it's not straight and it's all over the place, but it's really cool. We really like it. It's just putting silicone on this piece of broomstick. We're going to put these inside the tube in order to displace some water, so all the water is forced to the outside. We don't have to heat up so much water, so it creates more steam for distilling water and all the other things we need steam for. Alright, today we're going to test a couple things. I got salt water. We went to the beach, so I got some ocean water. We're going to try and turn ocean water into fresh drinkable water using distillation. So I have a condenser that I'm going to pull out once this thing gets up to heat. We're noticing that it takes about 1.5 liters to 2 liters to fill the tube. We're noticing it's a little too much water to keep that water hot if we want to get more steam. So we took these 2 broomsticks, cut them, and they displace about 500 milliliters of water, and they're not conductors. They won't absorb too much heat. We covered them in silicone so that they don't absorb water. And we're going to put those in the tube. There's actually a mark here. I glued this piece. Feels like it's glued pretty good. It's just like a bottle cap, so they're going to float up to the top and get stuck there so they don't come out. So just put the 2 broomsticks in there. And yeah, we're going to start boiling maybe with about 1 liter of seawater, and it's about 9:30 like I said. So this is going to be comparable to the other test I did, also at 9:30. Difference here is I think seawater, salt water boils faster, and we're going to be boiling less volume. Once I get up to a boil, I'm going to first boil with this can here. This can fits on top and still lets me take temperature readings. This is just to hold the heat in and doesn't let any water evaporate. After that, I'll take that can off and switch it off to my steam hood, and then I'll start condensing. And it's very exciting. Okay, so there's the solar device. It's already at 73 degrees. It's only been, I think 12 minutes or something like that, so it's heating up very quickly. I have 1.25 liters of seawater in there, and once it starts boiling, I'm going to take that cap off. It's just a steam cap, and I can put this on, which is my steam hood. So this takes all the steam pressure, filters it through this. Then I'm going to put this tube on top. That's going to run all the way here to here. So we're going to have cold water in here, or just room temperature water. And then we're going to force our steam through this coil. And when it comes out this end here, it should be distilled drinkable water. So from seawater to fresh water. Now this water also is going to heat up because we're running steam, high temperature steam through there. So the copper is going to dissipate and they're going to exchange temperatures. As this heats up, I'm going to start taking this off and I'm going to put it back in there as it boils. So it won't need to heat up as much. So once the thing starts running, it should be much more efficient. And I'm going to measure how much fresh water I can make out of salt water per hour, something like that. And that'll be our first real add-on and really useful part of this machine. And we're going to keep going with pressurized steam, and steam engines, and pumping. So this is our first real project. So this is about $5 worth of material. This is garbage. This is just a can that happens to fit perfectly on our tube. This is just a 3-liter Coke or Pepsi container, pop container that I cut the lid off. And this is the expensive part. This, I got 3 feet of copper tubing. I cut a piece off here, which is this piece here. And this was just 20 cents of rubber tubing. I'm hoping this is okay for the temperature. But yeah, using a lot of garbage, that's what I'm trying to do as much as possible to make these machines. Boiling like crazy. That's the kind of boil I was looking for. This should be able to create quite a bit of steam. Oh, that's great. Really impressed. The steam hood's on there. You can see all that steam. Might be hard to see on camera, but I can see quite a bit of steam coming out here. And it's, oh, quite a bit of pressure. hooked up the condenser so you can see it's already condensing just in the tube, so we'll probably need to insulate that. The best thing is if the condenser was really close. I should probably put on that chair because it's losing water, but if that water, it's just about to come off here. But I don't see any water down there. The steam doesn't seem to really make it to the bottom yet. I can see bubbles on the tubes. I don't know what that's from. Yeah, we'll see how it goes. Oh, way too much hose. There it is. So the steam in this coil is really starting to heat up this water. It's pretty hot already. So what we're going to do is we're going to take this out. Usually this would be done by some kind of valve and everything else. And we put it in here, and we're going to put it back in the tube. So now the tube doesn't have to heat up as much. This is where you get a cycle where you're condensing water and you're also heating up water to go back in the pipe. That's where you get a higher efficiency. All the steam is a low point here, so all the steam is really bubbling through the water here. It's really cool. It's all our pressure. And the sun is really, really hauling ass today. It is really hot. So I mean, this water, really hot. This pipe you can't touch. Sweet. So I'm just cutting this PVC by hand with this little saw I have. It's working great. So this is going to displace all the water in the tube. So we're going to go from 1.5 liters capacity in the tube to about 400 milliliters or less, and that hopefully will allow more energy to get into a small amount of water and boil very quickly to create the steam we're looking for. I'm just boiling the piece of PVC to make sure that it's not going to soften up, get mixed results. People say it melts at about 160 degrees, so as long as it's rock hard at 100, it should be good for our purposes, as displacing some volume in there. Alright, so I'm trying to make this tube now watertight. I have my silicone to seal, I have my epoxy to glue and hold it together. I'm going to sand size 220 sandpaper. So on one side here, I'm going to sand this so this fits, and I'm going to glue these two caps in to make that airtight. Then on the bigger side, which is going to go on the end, displace that water, I have this large cap which fits nicely in here. So glue and silicone that, and then I should have this airtight tube which can displace water for the steam pipe. Two-pipe design, it's boiling a lot. It's spitting up quite a bit. So I want to just basically measure the steam by measuring the water. So I don't want any water loss. So there's a couple drops here. I'm just going to skew my data a little bit, so at least it jumps out of there the better, but it's such a small opening between the two pipes that it's really easy for water just to shoot out of there. Oh wow. Got a bit of steam coming out. This looks like it could be producing steam. Lots of it. Wow, shit! Alright, that's bad. Really boiling. Whoa! I don't know how much water I should still put in it. It keeps spitting up at weird times. I don't think there's a lot in here because this thing here has lost its buoyancy. It used to go to the top. Wow! It's hot. Now it's kind of setting down. Shit. But I mean, the temperature is staying at 100, which means there should be enough water there to keep it at 100. If it was completely empty of water, it'd go up to like 130, 140, stuff like that. So, I don't know. It's kind of weird. You can see all the steam there coming out of the end of the pipe. It's been boiling for quite a while now. Just waiting for the water to get low, and then I'm going to add some more. We'll see if this creates more steam than the pipe without the PVC displacement. I only put half a liter of water in here, so it should be gone pretty soon. About 40 minutes in. Alright, so this is my first test for multiple tubes. I'm going to try 8 1/4-inch copper pipes. And I'm going to try this on the small garbage solar, so I'm going to put it out. And I don't have enough copper pipes, so I'm only going to use the front portion. I see how quickly these boil and how much steam they produce, and I might try this on the bigger one, but this is mostly to increase steam production. I like it because sun can hit maybe just on 1 or 2 of the pipes. They can heat up and boil with the other pipes staying cool, so we don't have to heat up as much water. So I'm going to need epoxy on the inside, or sorry, silicone on the inside to insulate them and keep them from sharing heat, stuff like that. And then I'm probably going to try this tomorrow. Put a bunch of silicone on the inside there. So we're going to slide this broomstick back in. Be nice and insulated and glued with silicone to the stick. Just seeing if you can boil. It's going up quickly. Seeing if flip-flop material can withstand the heat and try to make a piston out of it for the steam side. So hoping to get close to 100 or more. But yeah, 36. Spray painting little tubes. You don't really want to get too much inside the top. It doesn't matter that much. Oh, cool. Doesn't look like it's sticking that well. Just using the scrap wood I have here. Cut these two. I'm going to make this teeter-totter design for this vacuum steam engine. And hopefully I'll be able to use steam from the sun to pump water. This is about as simple as it gets. This is one of the first steam engines ever made. So I'm hoping I can reproduce it out of simple materials. I have all the different valve designs and everything, different pistons, so I have to see what works, but it should be fun. Here it is. Threw it together, just a rough put together of the first part, which is the teeter-totter. Now it's very shaky, but so basically this just pivots back and forth. You have the steam vacuum on one side, pump on the other side, and there it goes. Very exciting. Oh. Alright, so I'm just drying all the white glue. It's all set up, so everything's got lots of white glue there. I put water in these pop cans to put pressure to pull it all down as it glues. Should be good. It is boiling pretty good. There's big jets over there. So here are the pipes, and we only have half a liter of water in here. Heated up in 14 minutes. It started boiling in the sun. The sun's really strong today. Yeah, it's doing a really good job. And make sure we don't lose any water. It's getting very close to coming out of the pipe there. So I think I put a little too much water in. Really boiling. Wow. It's like the best boil we've had so far. I mean, if I was just doing a vacuum steam engine the way I want, I just take this steam and then I put it in a confined area and it contracts as it condenses 1,600 to 1, and that's all I need. I mean, I'd be able to do quite a bit of work with just this amount of steam. Just have a steam engine pumping water as this boils all the time, refill it every now and then, or have a closed system. Should work really well. Yeah, so I have to put this much higher, so it creates a shadow here, just to make sure that this water here, it's very close, doesn't boil over. Looks like it's gonna boil over. So yeah, I lose a lot of heat in sunlight because there's a shadow there, and also there's sunlight here that's missing. All this is missing the pipe, so that's just what I have to do to keep the water in the pipe. It's like a steam engine already. Pop, pop, pop. Yeah, she's losing a lot of steam. She's bubbling like crazy. Already used up all the water. Went up to 136 degrees and now added some water and she keeps going. So boiling's going very good. Boiling like crazy. But yeah, I wish I had two temperature gauges because I need to watch this. It's going to heat up. It's at 101 right now. And now I'm just checking out the little garbage solar too. So you got the whole family. You got the big one, got the little one. Like all I can do is say, that's hot. And that's about as far as it goes. Cool. What's that? Yeah, we don't like steam. Steam's evil. Yes. Oh, nice. Really good boil. This is with a 2-inch PVC pipe. Create a lot of steam. It's hard to film because the camera is getting covered in steam. It's not good. And yeah, really high angle. The sun's really high right now. Wow, there's so much steam coming out of this thing. All that sun focused on this small pipe, and then you get all that steam. What will we power with all this steam for free? The possibilities are endless.